been a lot of talk about why modern games are unoptimized and bad, running on terrible frameworks on really good hardware, and why games getting big all of a sudden, why the file sizes are becoming massive, like Call of Duty at 200 gigabytes, and why are games getting ruined by Unreal Engine 5. I kind of just want to go over some misconceptions and areas I see in a lot of these people that are talking about it. People who are obviously just not into programming or software development or any sort of game development and don't really understand what it means by optimization or file size and such. I have actually talked about file size before games and also dealing with Unreal Engine. But this case, I just want to focus on specifically optimization, what we mean by that. Are games utilizing it or are they unoptimized? How optimization works and such, because it's actually not as clear as you might think. So, optimization is not a new issue. We can see in this post, specifically about file sizes, that it was posted 11 years ago. So, people have been talking about it for as long as software has been around. And in this case, they're saying that games used to be 15 gigabytes, but they're now over 40 gigabytes. Obviously, nowadays, 40 gigabytes would be considered a small game, as we are easily approaching 100 gigabyte, 80 gigabytes. They're kind of the average in AAA games nowadays. So optimization is a very general term. It generally means two things, really: that the software runs faster, so a higher frame rate, or you're losing less memory, so that's your RAM. And so when we say, oh, these games are just unoptimized, what do you mean about it? If it runs at a low frame rate, that does not necessarily mean it's unoptimized, and that could be instead referring to something else, like the design choice of this game that results in it running at low frame rate. If you're looking at doing a simulation that calculates every single blade of graph's physics, that's going to be running very slow, no matter how well optimized it is. And if you think about it, if you're also depends on the hardware. If you're running on a single core CPU and you've got something that's just designed for multi-threading and all sorts, you can only utilize that one single thread of the core. Let's imagine the game is unoptimized instead, and that they're going to go through and optimize it. So I'm going to provide you a little simple example of this with just a little drawing. And here we have is the game window. The game window is just what you see. Imagine as you monitor and the game is running there, that is what you see. You see the player, you see all the grass, the trees, whatever. Well, there's obviously be stuff happening outside of the game window that you cannot see. This could be stuff like collision, but then think of it in terms of rendering. So that there's a lot of grass. So if it's a 3D world, there's stuff behind us that we cannot see. Is stuff still happening? So the first call to action would be making sure that this is not being calculated or edited on. So the world is not being sent to the geographic sky and be like, hey, render this, and it's not even in the window. So that means you're wasting resources on it when that does not need to happen. And that would save you performance. And also in terms of not necessarily rendering, but in terms of logic, collision detection, items, all this stuff that's outside of the player's view or just nowhere near them, nothing needs to happen. That can also be logged, and that can also save them resources. But in this case, the game's playable. The player can go through and play it all. And you might be thinking, why was this not optimized earlier? Surely that would save time, and now all the codes could be much larger and it may be more finicky to make it optimize. And maybe you're right. Let's say you do optimize early. Let's say something like collision detection, have like a nice quad tree and all this, and it all only checks collision for nearby enemies, and then later on that feature gets canned or has changed. So that implementation user optimization either can't be reused or just does not work as well as it used to. So all that time you put into it has just been wasted. So you got to think of like the design choices and possible change that happen, which what makes it difficult to optimize. You can spend a significant amount of time and realize actually this does not work as what I wanted to when more of the game has been developed or has expanded. The famous programmer Donald Knuth came with the idea that premature optimization is the root of all evil, and can be defined in short is that it's optimizing stuff before we know what we need to do with it, essentially. And it correlates to other things such as you aren't going to need it. So again, having stuff that you just don't need, like extra 1 frame per second for something that takes so long to implement, stuff like that, because you've done it too early and going far too granular in it. So the general idea is that you should build a piece of software that runs fine for what you want. It's sort of like a minimal viable product. Like it works at a good acceptable frame rate and performance, and then you can start looking at, okay, let's improve that further. So stuff like this can make games very expensive and just very time consuming to do, because you build that product, this minimal viable product, and then you need to spend time optimizing. So imagine for a large AAA game, very big one, that optimization just can't be done within a week. You need to build it, have it pretty much ready, then really probably spend like a year going through and optimizing it for the hardware that you've got, which is a very difficult and expensive task. I think a really good example of a game that we can see that did execute this really well was Street Fighter 6, because we look at the announcement for the first closed beta test, the first time it was playable, and when at least a good chunk of people's hands, there may have been examples before and like closed like conferences and stuff, but this was October 7th, 2022. The game officially released on June the 3rd of next year, so that is many, many months. In fact, so the game was almost a year playable, really, only a few months difference. That gave them plenty of time to make fixes and changes to the game. And really, at this state, I did play the A closed beta. I think it was the second one, and it was very good. It was very content rich with what you could do. It was limited to just the multiplayer, but it was like, it didn't feel very, there was no issues with the bugs. It had some things, but it was only minor. And I actually think at this point the game was majority done. All it was done, and they were just going through fine tuning things. Obviously, we'll never really know, but because they had so much time in advance, that by the time the game launched, it was amazing. Like, it ran fine. There was a few issues, but that's as expected with a large game. Even if you do spend that time going through optimize it, it's not until you get a very large user base that you find those kind of niche issues. And Capcom have continued this tradition as well, with Monster Hunter Wilds had a closed beta test October 2nd of last year. Game is launching in February, so not as long, but that's still quite a lot of time, especially for more of a single player game as well. Street Fighter 6 more of a multiplayer core focus, so they probably wanted a longer period of time to fix and balance characters. But with this, it's not. It's just it does have multiplayer components, but it's mainly a single player kind of experience, so you can play your friends, and so there's a less desire for that. But they're still giving it ample of time to go through, let players play the game, give them feedback, fix any bugs that are reported, and just constantly optimize it further. It's not the same for games that have very strict deadlines and tight development schedules like Call of Duty, Notorious, and with Battlefield, where these games do have betas, but they are like a month before the game releases. That is definitely not enough time to put any patches in, only a few minor tweaks to weapon balancing, really. See that the beta took place from, like, I think the 6th, and they had patches within that, which is even funnier. Like, you're patching a beta test, it should be really fine at that point, and then you get the feedback. But if you're spending time patching the development build of the game, not even the one you're really working on, then that's kind of some issues. But yeah, a month, hardly anything. The same with Battlefield, they did a month, and it's just, by the time the game comes out, they're not gonna have time to fix any of those things. And really, they're actually just there to get people to play the game and be like, oh, excited, and then pre-order it. And actually, if you wanted access to some of these, you did have to pre-order it. It's not really a beta, it's just an early demo of the game, I think. So with these examples, we kind of get an idea that if a game has a beta or demo months or even a year before it launches, it's perhaps a good sign that game's going to launch in a very stable state that is optimized, because they've released you an early copy and they're confident in their product, as opposed to releasing a beta that is like a month before the game launches, which it doesn't suggest that. It suggests that they're just wanting you to play a game, and if you enjoy it, come into it. If there's any changes they made, or not say changes, but any issues that you found or bugs that you suggest, they're not really going to have time to fix it at all, really. We have a couple of games that will be releasing, one that had given early copies and one that has been delayed. And the first one we'll look at is the delayed one, which is Assassin's Creed Shadows. I'm interested to see how this game launches. It was meant to launch in November of 2024, so last year. It's been delayed twice, and its now launch date is March 2025. And they've gone through and trying to iron out issues, as we suppose, in order to make this game excellent. This is sort of in their words. I'm curious on how well this game will do. I imagine that it was going to launch pretty buggy. It's Ubisoft, and they've had a history of launching buggy games, and that this was going to be no different, but this time they're spending time on it. I think it will be better than it did launch in March, but it depends if they are optimizing the game or making gameplay changes based on players' feedback, which has been rumored to have happened. Now, the other game, I'm not going to show it, but it's Kingdom Come Deliverance 2, and that game launches actually within 2 days, but they released review copies 4 weeks, almost 4 weeks before the game launches, which is a sign that they're very confident in their product, unlike Ubisoft, where they had to delay it because they aren't confident in that product. but time will tell if these games do perform well and are optimized at launch. So in the nice, perfect development world, you build your game with a minimal viable product, and you go through and it's like, time to optimize it because now we have this product and we know what we need to do, and you do that. That's an all clear, but what if the workflow is not great and you don't really know? And because seems to be quite a new thing, that is not exclusive to game development. So if we look at the world of software and specifically in web development and search React App Slow, React is a framework for developing web pages, you do get quite a few results of big channels like, why is every React site so slow? Why does your React app load so slow? React is slow. What now? Is there a way to prevent React app from lagging, slowing? React is slow. What to do now? Seems to be quite a common issue. As someone who has experience using React frameworks, I would say that a lot of these issues that it just enables it so easily and it's not obvious on why it's being slowed down. You followed the documentation tutorial and it doesn't really explicitly make it clear that this will have consequences later on down the line. And it becomes difficult to patch these out because you've built all this framework and realize, this is not how I should have done it, because it results in the web page constantly rendering when I press a key and it causes lag, or it constantly allocating memory that I don't know, and I don't see way into development. With some software and tools like Node.js and Python, you can install packages that people have made or that are available. So with Python, you can install a pathfinding package that just gives you the algorithms. You can just use it like that, just follow the documentation and you're done. And Node.js, I'll just install this package, npm install, damn, you got that, it does that. And that can be great, but it often results in, or can result, should I say, in unoptimized software because it just kind of lets you, it's easy, right? And there's a really good example recently that was a few months ago, so July actually of last year, in this thing. And in this code, which is called to regex range, and this is using Node.js and stuff, is that what they did was replace isNumber dependency. So what it does is check isNumber. So it was a single line change would save 400 gigabyte of weekly traffic, because this was a package that you could down 400 gigabyte with that one simple change. That is all. We look at the code, we can see that they removed a dependency that just did that, and it does this. And this simple change, it was only a few megabytes, but because they were getting so many downloads, it made that difference. It all added up. And that's because you have to download this package, and it actually adds on below to your software. So generally what I'm sort of saying is that in some tools and software and game engines, it's very easy to use the default or use what's available that may not be the best option to do, rather than implement it yourself. And with products and tools like DLSS and upscaling, that becomes very easy now. Now you can just upscale from a low resolution to a high one and get acceptable frame rates without actually going through and fixing those issues. Unreal Engine has Nanite, which automatically creates a level of detail of some sort, so you can put in these models and let the engine handle it. Is that such a good idea, or should you still create this level of details, and is Nanite maybe as an optional thing? These are worth considering, and this can create a workflow of bad unoptimized software or games. You're just using default, and the default maybe is just not the best approach. Obviously that doesn't mean we should make games and software from scratch or do every algorithm our own way. No, you can still use frameworks. You just need to be aware of the wider implementations that it may have. The isNumber is such a simple, small thing in that repository. It's like, just use this, it's got that. But then you think about it, actually, this is increasing our package size, so therefore when people are downloading it, they're downloading a tiny bit, megabit more, and that increases our traffic usage. If we remove it and just use that one line that we need, we can save up a lot of memory. So stuff like that. I think the other thing I've seen that is misconceptions is optimization and game design. Two different things. They're not the same, but people conflate the two. So that's the idea, like I said, of the simulation and the blade of grass, and that it was still running at low frame rate. They're kind of like game design choices. You want to be photorealistic and use 4K textures. That's going to have a consequence on the performance of the game. It's just something to think about when you're playing a very photorealistic, high definition game that's got all this dialogue and all that, and it runs poorly, and you're like, why do I need the latest tech? It's like, well, maybe that's because that's the design choice they've made. Is it the right design choice? I don't know. But it's just something worth thinking about, saying, it's unoptimized, but it's really like, there's only so much you can do. A 4K texture is still a 4K texture at the end of the day. That's going to take up a lot of memory, especially compared to 1K. That's 4 times the size. Therefore, that's going to take up like 4 times the file size as well. You may have seen this image before, which is like Western Game Dev has been here. How can you tell? It's because the file size is so large. I don't even know what game it is. 105 gigabytes, that seems normal nowadays. And this is just kind of like not true anymore. That, oh, Western Game Dev. No, it's just all AAA game devs. We've got games from the Japanese side that are also large like this. Ninja Gaiden 2, is it remaster, was announced. That's going to be like 90 gigabytes. And I've seen people say, oh, it's all because of these uncompressed textures. And I just don't think that's true. I do think the textures are compressed and all that. Maybe in some certain circumstances they aren't. I think Call of Duty on the PlayStation 4, not the latest ones, did have uncompressed sounds or textures, but there is a benefit in the fact that the CPU doesn't need to spend time decompressing it to then load it in. They can just directly load it in because it's already there. It takes up more storage, and that's like a different discussion about saving memory over saving processing power. So I do think these are more game design and an idea choice that results in these large file sizes going for that. Like I said, that photo registry post, got to use up more memory. And even the examples of Capcom I use, like Street Fighter 6, I think that's 60 gigabytes for a 2D fighting game. That could be considered quite a lot. It does have an open world, but not exactly big like Grand Theft Auto, so it's still very large. And Monster Hunter Wilds, which is more open world, that's going to be 140 gigabytes at launch. And Capcom that are been very good at releasing these games that are pretty well running well, and they're still got a large file size. I do think that that's the way it's going to be. There's only so much you can do to reduce that file size. I don't think they're optimization issues. I think they're game design issues, or not necessarily issues, because that's the style of the game, right? It's if you want that photorealistic, great visuals, great graphics, great audio, and all that, then it's going to take up memory. So really, to conclude, optimization is a time-consuming, expensive, and complex process. It's important to do, however, but we can see that just saying, hey, this game is unoptimized, it may not be true. And the reasons why the games or software can come out as unoptimized, stuff like workflow, I think is a big one nowadays. Stuff DLSS, you can just, you're cutting corners. React with the web apps, oh, I just use this, and you don't realize that you're re-rendering everything because it's not clear, stuff like that. And just time, it's telling your publisher, hey, we just need 1 more year just to optimize that game, and they're like, oh, is your game finished? You're like, yeah, well, release it then. Stuff like that. That's expensive, and with money being short, especially in the game dev scene, I guess not necessarily short, but costs rising, and there's been layoffs. They're looking to grow again. You can see why they wouldn't want to spend the year optimization. Maybe we'll see a change because those games that are getting that love and attention are doing very well. So maybe other publisher will look at it and be like, hey, we need to put our love and attention there as well. But big games, sometimes they just sell no matter what, really, because people want to play them. And so if you enjoyed that video, then do subscribe and like the video, and come along and check out some other videos that I've talked about, stuff like why I won't be making my dream game. Quite an important topic when it comes to game developing, idea of making your favorite game. But I won't spoil it too much. So I'll see you over there then. Yeah.